Hello everyone. So now we are starting on with the new topic. Give the heading spread risk and default intensity model. Give the heading spread risk and default intensity model. See, till now we have completed that structural model. Okay, till now we have completed structural model, and this one is going to be our reduced form model. Okay, so first of all, give the heading spread risk and default intensity model, and under this write down reduced form model. First of all, let us understand this part, reduced form model, and how this is different from our structural model. In the structural model, we are using the capital structure of the organization. Capital structure of the organization, like the whole debt, the whole equity, and the asset of the organization. Clear? You remember? But in the reduced form model, we are picking up a bond. We are picking up a single bond of a company, and then I am identifying that what is the default rate, or you can say probability of default of that particular bond. Over there we are finding out the default of the organization. Over here I am going to find out the default of a single bond. See, reduced form, this is the reduced, a subset of a very big organization, a subset of a very big organization. So over here I am trying to understand the default probability of a single bond. See, at the end what my agenda is to calculate the probability of default. Clear? Over here my agenda is same, probability of default. Over here agenda is same, to calculate the probability of default, but in a different way. In the structural model I am using the structure of the organization as a whole. Reduced form model, I am just taking the reduced form of the organization. Reduced form of the organization means a bond. What is the probability of default of that particular bond? Clear? Now we are going to cover up this topic in three parts. Number one is the spread risk. If you are issuing a bond and its spread is high, means the amount of risk is high, and the amount of risk is high means the probability to default is also high. See, at the end what I am moving towards, probability to default. Spread risk high means the bond is very risky, and when the bond is very risky, that means the probability to default is very high. Clear? Then we are going to study about that hazard rate, or you can say the probability to default. Basically over here we are going to use the term lambda. Clear? And then we'll come towards the CDS, that is credit default swap. It is also based on a particular bond. Okay, for every bond which is issued in the market and CDS is trading, its spread or its premium will tell you the amount of risk in the organization. If the premium is high, what does this means? The bond is risky, and if the bond is risky means the probability to default is also very high. Clear? So we are going to study the chapter in three different parts: spread risk, hazard rate, and CDS. Chapter is very simple, easy to understand, nothing complicated. Lesser time it will take, like as we have seen in the structure model, it took huge amount of time, but this part will take only smaller part of your time. Clear? Okay, so over here write down, we are going to use bond price, spread, hazard rate, CDS price to find out the probability to default. Clear? This is my agenda, to actually find out the probability to default. Clear? And with the help of the bond price we calculate the YTM of the bond, and then I'll compare it with the YTM of the risk-free bond, and then I'll get the Spread, clear? That will tell me about the PD. Hazard rate tell me about the PD. CDS prices will tell me about the PD. Clear? Now, if I want to calculate the spread, what I want? I want the YTM of a risky corporate bond, and minus the YTM of US Treasury bonds. Clear? YTM of the risky corporate bond and the YTM of the US Treasury bond. Clear? Now, one important point, they must have same maturity. Clear? If the risky corporate bond is of 10 years maturity, then the US Treasury bond which you will be using, that is also of the 10 year. Clear? Now, we can have many different types of spreads. Write down types of spreads. We can have many different types of spreads. Write down one by one. Number one is yield spread. Clear? Write down second, I spread. That is interpolated spread. Then we have Z spread. You have already seen them in your FRM part 1 preparation. Okay. Asset swap spread. Then CDS spread. Then OAS, option adjusted spread. Then discount margin. See, in this particular chapter, they don't require you to calculate this spread. They don't want you to calculate these spread, but out of which some of the spread you are already familiar with. Okay, in your FRM part 1, these 5 spreads you are already familiar with how to calculate. Okay, we have done it many times. Clear? FRM part 2 don't require you to calculate these spreads, but I'll show you 1 or 2 examples so that you will be able to recollect the concepts. Okay, now let us take one example of the yield spread. Okay, write down. Take an example of yield spread. So we have 2 types of bonds. One is XYZ, which is a corporate risky bond. Then we have US Treasury bonds. Clear? Now, time to maturity 20 years, and over here also 20 years. Time to maturity both 20 years. Then coupon rate 6% semi-annual, and this one 4% semi-annual. 6% semi-annual and 4% semi-annual. YTM given to you. Okay, suppose YTM is not given to you, but they have given you the price. You can calculate the YTM, but suppose in our case YTM is given to you 7.25% and 4%. So can you calculate the yield spread? See, first of the thing that you need to check is the same maturity. So maturity is same. One is the risky bond, another one is the risk-free bond. In that case, the yield spread is equals to 7.25 minus 4, that is 3.25%. Now, this XYZ bond is giving extra 3.25% to the bondholder. Why? Because XYZ is risky and they are paying risk premium, and they are paying risk premium. Clear? Higher the risk, higher the probability of default, and when the probability of default is high, what we'll do, we will add that into our pricing. We will add that in our pricing. You remember, expected loss will be added in our pricing, unexpected loss will be used to find out my required economic capital. So this is the expected loss, this is the expected loss, I'll price it in my bond. So what I'll do, I will increase the yield of the bond, I'll increase the yield of the bond. Clear? Similarly we can find out the value of the spread if suppose the yields are not same. If the yields are not same, then we need to do the interpolation. If the yields are not same, then we need to do the interpolation. Suppose we have US Treasury bond 20 years and its YTM is 4%. YTM is 4%, and there is one bond of 18 years, their YTM is 3.6%. Clear? Now XYZ 19-year bond, and its YTM is 7.25%. 19-year bond, its YTM is 7.25%. So means what? 19 lies in between them. So that means what? 0.4% belongs to 2 years, because you see the gap is 2 years. So this 0.4 belongs to 2 years. How much for 1 year? 0.2% for 1 year. So what I'll do, I will deduct 0.2%, then I'll get 3.8%. this one is the YTM of 19 year. In that case, what is the yield spread? In that case, what is the yield spread? 7.25 minus 3.8%. this is the spread of the 19-year XYZ bond. Clear? Similarly, we can calculate this Z spread, OAS spread, but trust me, not at all required the calculation of these spreads. Now, out of which there are two spreads which are new to us, okay, which we are not aware of this from beforehand. So what are those two spread? One is this asset swap spread, and one is the discount margin. Discount margin is very simple. Discount margin. Now suppose the YTM of a bond, YTM of XYZ bond is 10%, and currently the LIBOR rate in the market is 6.4%. Clear? Then what is the discount margin? It is 10 minus 6.4, that is 3.6%. means how much you will add to LIBOR, to reach to the YTM of XYZ, and similarly the asset swap spread is the spread on floating leg of the asset, means you remember A and B, he is paying fixed, and when it comes to him, he is paying floating, and what he is paying? He is paying LIBOR plus 200 basis point. This 200 basis point extra which he is paying, this is a spread in case of swap. Clear? So our first point of the topic is clear, that is different types of spread, how to calculate them, the meaning of the spreads. Clear? Hopefully we are clear with that. Now we will calculate the spread 01. You remember the concept of DV01? Means if you will change the interest rate by 1 basis point, what will be the change in the bond price? Over here you are also doing the same thing, but you are not changing the interest rate, you are changing the spread. That is your Z value. If you are changing the Z value by 1 basis point, what will be its impact on the bond price? This is what we are calculating. Clear? You can also calculate in a different way with the help of the CDS. If you are changing the CDS, what will be its impact on the price of the bond? Clear? One side you are changing the Z value to find out the change in the price of the bond. On the other hand, you are also changing the CDS to find out the change in the price of the bond. So means here you are playing with the spread to identify its impact, its sensitivity towards the bond price. How much bond price is sensitive to the change in the spread? How much bond price is sensitive to the change in the spread? Clear? So now let us take an example. Suppose the current price of the bond, you are given with the current price of the bond is $92. Current price of the bond is $92 and your current Z spread, is 207 basis point, or you can say 2.07. Clear? So you can change only 1 basis point, means you have to make it 2.075 and 2.065. Clear? So that you can see that now the difference is only of 1 basis point. The difference is only of 1 basis point. Clear? So with these two, Z value, Z spread, you will calculate the price of the bond. When you will increase the interest rate, bond price will decrease. When you will decrease the interest rate, bond price will increase. So when you will increase, the new bond price is 91.93, and when you will decrease it, the price is 92.14. Now this gap, calculate this gap, $0.21. So means if there is a 1 basis point change in Z spread, bond price will change by $0.21. Bond price will change by $0.21. So conclusion, lower the Z spread, higher the spread 0.1. Lower the Z spread, higher the spread 0.1. Why? Because over here you see spread was 2.07 and now it will become 2.075, a very minute change. But suppose the spread was only say 0.01, spread was only say 0.02, let us say. Okay, you will increase 1 basis point, it will become 0.025 and 0.015. So you see there is a huge change, percentage wise huge change. So because of which, when the Z spread is lower, this part is lower, higher the spread 0.1, higher the spread 0.1. Now spread 0.1 also known as DVCS. Earlier you remember DV01, this one is DVCS. CS stands for credit spread. CS stands for credit spread, and DVCS exhibit convexity. Why convexity? Because you see that at lower values the impact is high, at higher values impact is low. That's why it exhibits convexity. You can write down why it is convexity, because at lower Z spread impact is high, and at higher Z spread impact is low. Clear? Okay, so this was more or less an introductory session where I have given you the introduction. We'll carry forward this lecture in the next lecture. We'll continue to understand that how this spread, with the help of this spread, how we'll be able to calculate the probability to default, and so on. We'll move ahead. Okay, so I'm ending this lecture here. Thank you.